Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 16 of a unit motion in a straight line. So let's begin with today's class. Today we are going to discuss about the motion under gravity. This is the second class of the same topic, motion under gravity. In the previous class, we have gone through the various numericals and the basic informations about the motion under gravity. So before we go to the advanced applications of the motion under gravity, first let's revise and let's have what are the formula what we are having. Let's say first consider that upward motion of an object. We have this relations v is equals to u minus gt, minus because velocity is in upward direction and gravitational acceleration that we call as a g is in downward direction. So this v is equals to u minus gt, h is equals to ut minus of half gt square, and v square minus of u square should be is equals to minus of 2 into g into h. And I know that at maximum height, v final would be a 0. I know this. At maximum height v final would be a 0. These are the relations for the upward motion, and from this we have two very important relation, that is time of flight. One of it would be a 2u by g, and the other relation would be h maximum height, that would be is equals to u square by 2g. I hope these things are clear to you. Is it? Now this is the location where final velocity would be a 0. Now let's understand the downward motion of an object. Let's say this is height h and it has been traveling from here to here. So I'm having a relation as that h is equals to ut plus half gt square, v should be is equals to u plus gt, v square minus of u square should be is equals to 2gh, as well as h in nth second is equals to u plus g by 2 into bracket 2n minus 1. Now in this case, one of the very important aspect is, if object has been dropped from certain height h, my initial velocity, that is u, would be equals to 0. So we already know this, we have gone through this. This is just the revision point of view, that these are the relations, and we are going to take a help from this guys to do the next questions. Yes, shall we begin? Let's move on. Go with the data what they have given. Go with this. What the question asks is, a body projected vertically up with a speed of 58.8 meter per second. Yes, it is moving in upward direction. After 2 seconds, if the acceleration due to gravity of the earth disappears, okay, the velocity of the body at the end of 4 seconds. So let's have a rough sketch of it, and we are going to solve this. So this is the object that has been thrown in vertically upward direction with a speed of 58.8 meter per second. This is the journey of 2 seconds, and this is its journey of remaining 2 seconds, though it is from the 2 seconds to 4 seconds. So what you knew is that up to here gravity is there, and if gravity is there, gravity must be pulling it in the downward direction. So what I can write is v is equals to u minus of gt. So initial velocity, it's a 58.8 minus of g is 9.8, because they have not given that take g is equals to g is equals to 10, so I cannot have it as a 10. So it is 58.8 minus of 9.8 into 2. So this would be equals to 58.8 minus of 9.8 into 2. It's a 19.6. And if I subtract that, it's a 39.2 meter per second. This is at the end of 2 seconds. This is velocity of a particle at the end of 2 seconds. Now, but you require what would be the velocity from 2 to 4. As you might aware that from 2 seconds to 4 seconds, gravity is not acting on an object, and if gravity is not acting on an object, then velocity must remains the same. Velocity must remains the same. So velocity at 4 seconds, that means from 0 to 4 seconds, it is the same, that means 39.2 meter per second. I hope these things are clear to you. Is it? Yes? Shall I add something for you people? Shall I? Thank you. Let's have a look that in this question, find out distance traveled in 4 seconds. You need to find out distance traveled in 4 seconds. I hope you can do it. Yes. Divide your journey into 2 segments. First segment would be of 2 seconds where gravity is there, and another 2 seconds where gravity disappears. It's from 2 seconds to 4 seconds, and the things will be done. Yes? Okay, great. Let's move to the next question. What did it say? It says that a body is thrown up with an initial velocity of 20 meter per second. The speed of the body in meter per second when it has reached 3/4 of the maximum height. Okay, so it has been released with an initial velocity of 20 meter per second from here. This is 20 meter per second. It must be moving like this and will come back to again the land. And what do you require? You require the speed of the body. When it has reached 3/4 of maximum height. It should look something like this. This is h, and this must be 3/4 of h. How can you do it? Yes? Any option? What you can do is that this would be the final velocity v, and this would be the initial velocity v. So what I can write is it's a v square minus of u square should be is equals to 2 into g into h. Final velocity that I don't know. That is what I am looking for. U square, it's a 400. This is equals to 2 into g into h. This is 3 by 4th of the maximum height, h max. So this is equals to 2g into 3 by 4 multiplied by h max. H max is u square by 2g. This is equals to v square minus 400. So this is 2g would be a gone, and this is equals to let's solve it on the next slide. It's a v square minus of 400 should be is equals to 3 by 4 of u square. So this is equals to 3 by 4 multiplied by u square. U is the initial velocity. Which is it? It is a 20. So this is 400. Yes. So that should be is equals to 3 by 4 multiplied by 400. So this is this 4 and this 400 will go on, and this is 300. So this is 300, and this is equals to v square minus of 400. I hope these things are clear to you. Yes. One more thing. When it is moving in upward direction, when this is moving in upward direction, g must be acting in downward direction. So I need to consider this g as a negative. I hope those things are clear to you. Yes, this should be a negative one, and as it is a negative one, if I solve this, it's a v square equals to 400 minus of 300, which will give me 100. So this v should be is equals to 10 meter per second. This could be the answer. This v is equals to 10 meter per second. Yes. Can you do this? Can you? Are you sure? Great. So I hope these things are clear to you. Is it? Can it be done by you people? Yes. Okay, let's move to the next question. Very good question. Go with the data, and first have a rough sketch of this, that what data has been given and what can I do. Go with this. What this says is a stone projected vertically up from the ground reaches a height y in its path at t1 and t2 seconds from the ground. Okay, you need to find out the height y. How can you do this? First, have a sketch of it. It is something like this. This is the height y, where it is available at two different times of its journey. One of the time is t1, and another time from here to here, it's a t2. What you require a y. Yes. How can you do this? First, let we complete this application by all point of view, that whatever this is the application where they are going to ask h max first, then they are going to ask that what would be the initial velocity, then again the y, it is in the question only. Yes, so we are going to cover each and every question of this topic. Yes, so this is t2 and this is the t1. So if this section and this segment is t1, this must be a t1, that you know. Yes, so now tell me, what is time of flight? I know that time of flight is equals to t1 plus t2, and if it is t1 plus t2, it can also be written as 2u by g. This is 2u by g. So if I write down the u, my first answer, it's a g multiplied by t1 plus t2 divided by 2. Yes, even a u can be asked. This u is equals to g into bracket t1 plus t2 by 2. I hope this thing is clear. Is it? Is it? I hope this thing is clear to you. Is it? Great. So this can be done now. Let's look at the situation. It is the situation. This is the height y, and this was the time t. What you can do is to find out the y. Y is equals to, you know this, ut1 minus of half into g into t1 square, and you know that u is equals to g into bracket t1 plus t2 by 2. I know this is the lengthier calculation. But this is the way. How can I do this? But don't ever try to do this. Just remember this. It's a y is equals to 1 by 2 into g into bracket t1 into bracket t2. Yes. If I replace this value of u in this relation and I just solve this, I am having this y is equals to half into g into t1 into t2. I hope this will help to you. Yes. Let's find it out. H max in this situation, that they asked that in previous question. Find out maximum height attained by an object. So, shall I redraw the situation? Shall I? Okay, let's have a look. This was the t1, this is the y, and this complete would be a t2. You require this. This pick is required. How can I do this? If you remember, then I am having a relation which is h max is equals to u square by 2g, and for this application my u should be is equals to g by 2 multiplied by t1 plus t2. Yes. So let's replace the value of u and find it out, that it is a g square by 4 multiplied by t1 plus t2 whole square multiplied by 1 by 2g. Yes, this is the g. So the terms remains where g multiplied by t1 plus t2 whole square divide by 4 to 8. This is the h max. Any other option? Any other alternate? Any other? Yes, if you wish you can do this with h is equals to half into g into t square, where t should be is equals to time of ascent. This is the another approach to do this, or time of descent, and you can easily have this because you are having a time of flight. So if I am having a time of flight, I can easily get a time of ascent or time of descent, and the rest amount of thing I can do it. Yes. So please remember this. This is very, very helpful to you. Yes. Let's look at the next question, what the data is telling to us. What this says is that this splash of the sound was heard 5.35 seconds after dropping a stone into a well which is 122.5 meter deep. Velocity of sound in air is. Can you understand the question? To you, what they says and what they require, and what they says, that this could be the situation that here it is a well, and you might be somewhere here, and you are dropping a stone. That means u is equals to 0 for you into a well which is 122.5 meter dip. It's a 122.5 meter dip, and you require to find out velocity of sound in air. So what happens first? When you drop this stone will travel like this. Yes, and it will touch here. So what you can have is that h is equals to ut plus half gt square. I should write this as a t1. Here u is equals to 0, so this equals to h equals to half into g into t1 square, and this t1 should be is equals to root of 2h by g. As soon as the stone has been struck to the water of a wall, a splash has been developed, and this will moving in upward direction, and I'm going to hear the splash. So that means I can write like this: velocity is equals to speed is equals to basically distance by time. Here my distance is h, it's a 122.5, but keep it as an h. V is equals to h by t2. So this t2 should be is equals to h by v, and my total time, that is the given that 5.35 seconds, that would be a summation of this two. So t should be is equals to t1 plus t2. I hope these things are clear to you. Is it? So now what you require this velocity. So let's put up the value and solve this. It should look something like this. This total t should be is equals to root of 2h by g plus h by v of sound. So this is 2. My h was 122.5 meter. So this is 5.35 seconds. That is equals to 2 into h. So this is 245 divided by 9.8 plus 122.5 divided by sound. I just solve this, and the answer would be 350 meter per second. I hope these things are clear to you. Is it? Yes, this is the question that even this question can be asked when we are studying the unit, that is waves. It's a last unit of 11th class. Yes, I'm not pretty sure, but you may have gone through this question while you were studying in class 9, because even class 9 you are having this unit of waves, and technically they were teaching only the sound waves. Yes, so this might be the question at this point of time, and you may have did it, not sure. Okay, so let's move to the next question. Are you ready? Let's move on. Let's say an object has been dropped. There are two locations. This is A, this is B. This is A, this is B, and object seems to be here, seems to be at point A when it has been traveling for the t1 time, and object seems to be at t2 time from again the beginning at point B. I need to find out distance between A and B. Assume that object has been dropped from certain height. Yes, this is what they require. How can I do this? How can I do this? So let's say this is suppose this is x1 and this distance, this is x2. So if I write for the x1, if I go for the x1 first, it is x1 is equals to ut plus half g t1 square. So this is x1 is equals to u t1 plus half g t1 square. As u is 0, this x1 should be is equals to half into g into t1 square, and this is it. X1 is equals to half g t1 square. Now what can I write for x2? It is the same thing, it's a half into g into t2 square. This is the x2. Yes, because my u is equals to 0, as my u is 0. Now what I require? I require x2 is equals to half gt square, but this distance is not alone in x2 because we have considered x2 from here. So what I should write is x1 plus x2 should be is equals to half into g into t2 square. Now what I require a distance between a and b. So basically I am interested in x2 only. So what I can do is, I know that x1 plus x2 should be is equals to half into g into t2 square. I know the value of x1, it is an half into g into t1 square plus x2, that should be is equals to half into g into t2 square. So if I find it out the x2, it should be a half into g into t2 square minus half into g into t1 square. So this is equals to, let's take half into g as a constant and find it out, the t2 square minus t1 square. This would be the answer of x2. I hope you have been at the same answer. Are you? Can you do this? Are you sure? Can you do this? Okay, let's look at the next question. Let's look at this question. The data is given that a ball is thrown straight upward with a velocity v, with a speed v from a point h meter above the ground. The time taken for the ball to strike the ground is. Now what all they have given is, what all they have provided is that, let's say this is certain height h, this is the height h, and they have thrown this ball in vertically upward direction from this height h with speed v. They require the time taken by the ball to strike the ground. That means this should be the motion. Yes, and this time is required. So how can you do this? First thing that we should always consider is that if you are going to write a relation like h is equals to ut plus half gt square, this relation is absolutely correct, no doubt in it, but you always respect a sign convention. Now what is sign convention? Let's look that you have started your journey from this position and you are going to ended up at this position. This is the initial position and this is the final position, that you understand. This is initial and this is final. Now as we discussed previously that these are the relations for displacement, not a distance. So if I consider this is the initial position, this is the final point, and as it is in a downward direction, that must be considered as a negative. So you have started it with here, you have ended up here, so your displacement would be an h, but as it is a displacement, that should be considered as a minus h. A first thing, I hope you understand this. You are throwing an object in upward direction, so let's take this u as a positive, h as a negative, and as soon as object is moving in upward direction, g always acts in downward direction. G always acts in a downward direction, so G would be taken as a negative. I hope this is clear to you. So let's look that what we have done is that this is minus of h is equals to ut minus of half gt square. So u they have given as an v, so I have written it as a minus of h is equals to vt minus of half gt square. So if I solve this, what I can have it, let's say this is minus of 2h is equals to 2vt minus of gt square. So if I solve this, it's in gt square minus of 2vt minus of 2ah is equals to 0. If you look at this carefully, this is the quadratic equations, and if it is a quadratic equation, let us to be compared this with the ax square plus bx plus c equals to 0. Here whole the relation is with respect to time, so let it to be compared with the at square plus bt plus c, and that would be equals to 0. So if I compare this, please do not make a mistake. When you compare the terms, you need to compare it with their signs. Let's this is a, that would be plus g. Here it is a b, so b should be taken not only a 2v, it should be a minus of 2v. I hope you understand this. Then c, it's a constant, that should be equals to minus of 2h. So a is equals to g, b is equals to minus of 2v, and c is equals to minus of 2h. Yes. Now to solve this, we have one of the delta. I know you might knowing this. If you don't know, let's have a look. First you need to find out the delta. Delta is the b square minus 4ac, and you are going to have a two roots. That means two solution of this relation, that is alpha beta, and that relation will be minus b plus or minus root of delta divided by 2 into a. So here there would be a two roots, here there would be a two solutions of the time would be there. So t is equals to 2 into v, that is a value of b, plus minus under root of b square minus 4ac. I have put up the value and divide by 2 into a, that is 2 into g. I hope these things are clear to you. Is it? Do you find any difficulties? No? Yes. So let's move on. So what I can have is, that is t is equals to v by g into bracket 1 plus under root of 1 plus 2gh by v square. And while solving this, one of the value would be a positive and one of the would be a negative. When I consider that two options, that this is the positive, this is the negative, yes, but we are finding out the time, and time cannot be a negative, so this would be the correct answer. I hope this is clear to you. Please understand that this is the question which will take an ample amount of time to be solved. This is the question which requires a good amount of time. So while doing this, you must understand that this question will certainly take 2 to 3 minutes, at least 2 to 3 minutes of your time, and you don't have any alternate. So what you can do is, you can, when you assess the examinations, when you are writing up the examination, when you are appearing for it, initially leave this question and attempt all other questions. Mark on this question, so at the end of the examinations, if time permits, you can go for this. Otherwise you can skip this, because it might possible that, let us suppose this is an examination of medical examinations for the NEET. If I am going to solve this question and it takes 3 minutes, that means if I have not attempted this questions, I can attempt, or I may attempt 3 another questions, and that 3 another questions, if they are the correct, that can gift me a numbers of 12, and if it is correct, this can gift me a number of 4 only. Yes. So while appearing for an examination, you must be calculative that which questions should I solve, which questions can I leave, and I can attempt it at the end of the examinations if time permits. Okay, so let's move to the next question. Keep all these things in your mind, and let's look at the next question, what the data is telling me. The question is, that a ball after having fallen from rest, yes, that is, it has been traveling from the rest, it should be u would be equals to 0 under the influence of a gravity for 6 seconds. For 6 seconds it crashes through a horizontal glass plate and thereby losing two-thirds of its velocity. It has been lost two-thirds of its velocity. So you must be clear with that one-third of velocity will be available with it, because it has lost two-thirds of its velocity. And then if it then reaches the ground in 2 seconds, height of the plate above the ground is. So this is what they require. Please have a rough sketch of it. Please have a rough sketch of it. Yes, what is the situation? That the situation is that this is u is equals to 0 and this would be the glass plate. The ball has been traveling from u equals to 0 under the effect of gravity only, and it has traveled for 6 seconds. This is the its journey for the 6 seconds. Now here whatever would be the velocity, he has lost two-thirds of velocity, and when it is traveling from this, it is traveling with only one-third of the velocity, and then it reaches the ground. It reaches the ground in just 2 seconds. So what you required? You required this height. This is the h. This is what all you need. So how can I do this? How can I do this? What I assume is that let's find out this velocity, and this velocity can be calculated as v is equals to root of 2gh, because v square equals to u square plus 2gh. Yes. So but before this I required this h that I don't have. So first, on a very basic step, I need to find out this h, and that h can be calculated as h is equals to 1 by 2 into gt square. Now g, I have not been permitted to take a 10, so I should go with the 9.8. So this is equals to 1 by 2 multiplied by 9.8 multiplied by square of the 6. It would be a 36. So this would be the h. H would be equals to 176.4 meter. Yes, and now as I am having an h, I can calculate the velocity. This velocity would be equals to root of 2gh. If I put up a value and solve this, it would be a 58.8 meter per second. Now I know that on hitting the glass plate, my velocity would be decreased to v-third only. So it would be a 58.8 divided by 3, approximately it would be a 19 meter per second. Now what I required is, I required this distance. Let's say this is h dash. Yes, it's a height of the glass plate from the ground. It's an ut plus half gt square. Yes, ut, it's a v by 3, which would be approximately 19.2 meter per second. This is 19.2 multiplied by 2 plus half into 9.8 into 2. Yes, again this is 39.2 plus 19.6, which will give me a 58.8 meter. I hope those things are clear to you. Yes. Did you approach in the same manner? Do you? Or have taken some another path? Yes, but do you understand this? How this can be done? Are you sure? Can it be done? Can it? Okay, great. Let's have one more question. Go through this quick and accurate. What the data is given, there's a ball is projected vertically upward with a velocity of 25 meter per second from the bottom of a tower. Yes, a boy who is standing at the top of a tower. The thing may be something like this. The person is here, and here the ball has been thrown in upward direction with a speed of 25 meter per second. Yes, next, a boy who is standing at the top of a tower is unable to catch the ball when it passes him in the upward direction. Okay, so at this instant he could not catch it, but the ball again reaches to him after 3 seconds. Okay, so at this time, so here to here, this time duration is 3 seconds. This time slot is of 3 seconds when it is falling. Now the boy catches it. Okay, then the height of the tower is, this is the h. Yes, I hope these things are clear to you. So if you consider what would be the situation, what would be the situation, what all they have given. Yes, so what all they have given is, they have given first thing, t2 minus t1 is equals to 3 seconds. I hope you remember this application, that this is the same application that I have been throwing the ball from here. It reaches to a certain height at two different interval of time. This is t1 and this is t2, and then we do everything. Yes, so my time of flight, it is equals to t2 plus t1, which would be 2u by g, as my u is the 25. So this is 2 into 25 divided by 10, which will give me a 5 seconds. So we have a two relation at this point of time. One, it's a t2 minus t1, which will give me a 3 second, and another, that would be t2 plus t1, that would be a 5 seconds. So if I solve this, just add this 2 would be a cancelled, and this 2 t2 should be is equals to 8. So from this I can have t2 is equals to 4 seconds, and if t2 is 4, t1 is 1 second. Yes, then I have a two option, whether I can go with this h is equals to ut minus half gt square, or even you know this relation, h is equals to half into g into t1 into t2. I hope you remember this. It's a 1 by 2 into 10 into 4 into 1. It would be a 20 meter. So this would be the answer. Is it clear? Is it? What was your answer? What was it? Is it the same? Are you sure? Great work. Let's move to the next question. Do it fast. So go through the data first and then try to attempt this. What the data is telling to me is that a person sitting on the top of a tall building is dropping the balls at regular intervals of 1 second. Okay, every 1 second he is going to drop the ball. When the sixth ball is being dropped, the positions of the third, fourth and fifth balls from the top of the building. Yes, he said when the sixth ball is just being dropped, you need to find out the position of third, fourth and fifth ball from the top of the building. So what can I have? Let's have a rough sketch. Yes, this is it. So this is the first ball, this must be the second, third, fourth and fifth, and sixth is just being dropped. So what I can assume is that he is dropping the ball on every second. So this is 1 second, even this is 1 second, this is 1 second, this is 1 second, and this is 1 second. So if I consider fifth ball, from the fifth ball, it would be equals to half a gt square, because when you are going to drop something at that point of time, your initial velocity will be equals to 0. So if initial velocity u equals to 0, you can have this, it's a half gt square. So this is 1 by 2 into 9.8 into 5 square, it would be a 4.9 meter. Now let's talk about the fourth ball. So this is equals to, this is the fifth ball, this would be the mistake, and this would be taken as a square. Yes, let's talk about the fourth ball. It's an again 1.2 into 9.8 into 4, and this would be a 19.6 meter. Let's talk about the third. It would be a 44.1 meter. Yes, I hope these things are clear to you. One more alternate option. Anyone did it? Yes, anyone? Let's say this is x, then it would be a 3x, then it would be a 5x. If it is a 4.9, this is 4.9, this is 4.9 multiplied by 3, and this 4.9 multiplied by 5, then the answer would be available. Yes, x, 3x, 5x, 7x, and whatever the distance they were asking about, we can have all those. I hope those things are clear. Is it? So can you do this kind of questions? Are you sure? Okay, let's have one more question. Look at this, what the data is given. Go through this. What the data is given, that a balloon is rising vertically with a velocity of 9.8 meter per second. A packet is dropped from it when it is at a height of 39.2 meter. The time taken by the packet to reach the ground. Yes, this is what they have asked. Now tell me, how could I do this? The situation is, let's say this is the balloon and it is moving in upward direction, and it is moving in upward direction with a speed of 9.8 meter per second. When it is at a height of 39.2 meter, let's say this is from ground level, it is at 39.2 meter, a packet is dropped. Now at this position, the word dropped is being used to complicate the things, because as a student what you are considering is that when and when dropped word is there, u is equals to 0. But this is not the case at this position. Why? Because here you are sitting, that means your packet is sitting in somewhere where this object is moving. So at this point of time when packet is being dropped, it is having a same velocity as that is having by a balloon. I hope these things are clear to you. Is it clear to you? Yes. So what you need to do is that let's write out the relation h is equals to ut plus half gt square, and consider any one of the direction as a positive and another as a negative. Let's suppose I consider downward direction positive, downward direction as a positive, and upward direction as a negative. So my downward direction would be this would be the distance. This is 39.2. As ball has been dropped but balloon is moving in upward direction, so this u should be is equals to minus of 9.8 into t plus half into 9.8 into t square. So if I solve this, I can have this relation. It's a t square minus of 2t minus of 8 equals to 0. Now according to the quadratic equation that we have done previously, that I need to find out the delta, which will be calculated by b square minus 4ac, and then I need to go for the alpha beta. It's a minus b plus minus under root delta by 2a. I hope these things can be done by you guys. Yes, so this can be done, and answer can be solved. Yes, you can reach to the answer for sure. I hope this is clear to you. Is it? So can you do this kind of thing? Are you sure? Okay, let's have a last question. Of this unit, motion under, of this section, and this unit, motion in a straight line. So let's go through it very, very carefully. A stone is dropped from a balloon at an altitude of 280 meter. If the balloon ascends with a velocity of 5 meter per second and descends with a velocity of 5 meter per second. Oh, there are two different cases. One case in which balloon is moving upward, and another case where balloon is moving downward. Then time taken by this stone to reach the ground in two cases respectively are. Yes, this is the same question that we did previously. Yes, this has been given that my height is 280 meter, u is the 5 meter per second, g they have given that you can take a 10 meter per second square. So let's take a first case when balloon is moving in upward direction with a speed of 5 meter per second. So if I write a relation h is equals to ut plus half gt square with correct sign convention, this would be minus of h is equals to ut minus of half gt square. Here I have considered downward direction as a negative and upward direction as a positive. You can take or you can choose your sign convention according to your convenience. There is no rule that in this situation this direction should be considered as a positive and this as a negative, something like that. No, it is not that. So if I solve this, I could have a two options. It would be a t is equals to 8 or t is equals to minus 7, but this could not be a negative, so this would be the answer. Same way I need to calculate this when the balloon is descending with u is equals to 5 meter per second, and I have did the same thing. I hope you are even going to perform the same thing and you will be having an answer. Yes, So can you do it? Are you sure? Are you sure? Yes. So this is all about the motion under gravity section. In the next sessions we are going to discuss about the relative velocities and the previous year asked questions. So till then, thank you, bye bye, have a good day, take care.